Okay, what we're going to do to start out with today is walk through the frequently made mistakes for assignment 3B. And this is one that you've no doubt noticed is more complicated than other stuff that we've had so far. So there's lots of things to address. So let's go ahead and start with the top. As usual, please make sure you document your code thoroughly. People are doing a better job, but make sure you do that consistently. And especially on assignments like this, it really helps to understand what you think you're doing. Here's something left over from assignment, I think it's 2A maybe. This has the wrong parameter for the list. So future takes a parameterized type. So you need to make sure you put the right parameters in here, somewhere around here. So make sure you put that in, and that will then help quite a bit. So make sure you fix that. Now let's move on to things related to this assignment. Make sure that you use the proper types. So in this case, don't use integer. Excuse me. Don't use integer. And also make sure that you fulfill the specification comment. Above here is the specification comment. Should put it in there so you don't have to hunt for it. It says make sure that this field will ensure its values aren't cached by multiple threads. So that's a very important hint. So please make sure you follow that. And this implementation down here has a similar problem, but even more problematic. It also uses static for some strange reason. Remember, static is not what you want. Static is going to be a class instance variable, not an object instance variable. So if you say static, it's going to have one instance of count for all the different objects that are fair semaphore MO objects, and that will clearly be incorrect. And then you also have to make sure that you put the right type qualifier on here to make sure this field will ensure its values aren't cached by multiple threads. And that will actually be tested for a little bit more automatically in the next version of the skeletons. For assignment 4, it'll do a check to make sure you do that correctly. There's some problems down here with the constructors of fair semaphore. There's important things that are missing here. If you run your program, it will probably die a horrible death and you'll get a Java null pointer exception, so please make sure that you don't let that happen. But you have to put the right thing in here. Whoops, and I made this twice, don't need to have it twice. And then down here, this has a similar problem in that this program is going to crash and burn because you're not initializing wait queue properly. So make sure that you give wait queue the appropriate value, and definitely giving it a null value is not going to make things work. I'm a little bit befuddled as to why people are having these kinds of problems, because this is stuff that would be trivially caught if you ran the unit tests. So if you're having these kinds of really weird problems, it's probably an indication that you're not running the unit tests, or if you are running the unit tests, you're not thinking carefully about what the outcome of said unit tests are. So please make sure that you're running those tests, and if you have problems, you're coming to office hours to get them resolved, because all your unit tests need to pass. Okay, let's come down here and take a look at this particular method. So acquire, for some strange reason, is being changed. There's no to-do tag in acquire, so you don't have to do anything to it. So please don't modify methods that don't have to-do tags on them. One less thing to have to worry about. Here's a very lightweight implementation of acquire uninterruptibly, which is missing pretty much everything that needs to be there. This is something that should be almost identical to what you had in assignment 2B. The assignment 3B, acquire uninterruptibly, should be more or less exactly the same as assignment 2B. So make sure you take a look at that. If you had problems, of course, with assignment 2B, then you need to be coming to office hours, because that's left over from a while back, and you'll lose lots of points, which you don't want to do. Here's another problem here. You need to follow the spec. It says use a loop, or using a loop to ignore interrupted exceptions. This doesn't have a loop, so it doesn't meet the specification. And definitely do not be using recursion here. It's clever, but probably too clever for its own good, especially because you could, at least in theory, overrun the stack if it kept getting interrupted over and over again. That's unlikely to happen, but please don't use it. Recursion unnecessarily. And this is missing something important here as per the previous assignments. So you need to set a flag and then make sure you interrupt the thread if the flag is set because an interrupt occurred. Let's see, down here, similar kind of thing. This finally block needs to be changed, and needs to be moved outside of the loop, moved after the loop. That's the right place for it to go. And yet more problems in acquire uninterruptibly. For some strange reason, this code is just sort of cutting and pasting the code from acquire and sticking it into acquire uninterruptibly with a catch. I'm not even sure what's going on, but this is not what you should be doing. You should implement this in terms of acquire as you did with assignment 2B, and it also doesn't meet the specification comment above, which says to use a loop. All right, we are now on to another method, which had a bunch of problems. A lot of people were doing strange things here. So if you're doing the undergrad version, you should be using Java built-in monitor objects, in particular the synchronized keyword portion of that. So don't use a reentrant lock at all. That doesn't make any sense, so that should be eliminated. This implementation doesn't meet the specification either. What you should be doing here is synchronizing using the synchronized keyword, because it's the undergrad version, and then you should just be forwarding to try to get permit unlocked. And try to get permit unlocked assumes the lock is held by try to get permit, and then it just does the logic. The try to get permit unlocked does the logic, which will then check to see if the queue is empty and the permits are greater than 0. And again, we don't need a reentrant lock because you should have used a synchronized statement, so there's no need to unlock anything. Okay, now let's take another look at another problem. This, I'm not sure what this is trying to do, but it's clearly wrong at many different levels. First of all, it's not synchronized. It's just checking to see if the thread holds a lock, but that's not what you want to do. You want to synchronize it, not check to see if it's holding a lock, because it couldn't possibly be holding a lock because no lock have been held. So that will always be false. And then the logic here, which is just subtracting 1 from m available p, that's incorrect. That's just wrong, but that code shouldn't be there anyway. It should be calling try to get permit unlocked. And this implementation also doesn't fulfill the specification in that it doesn't synchronize anything. So that's incorrect. Now this is the grad student version of try to get permit, and this approach correctly acquires a lock. That's good. Calls down to try to get permit unlocked, but then it always unlocks the lock. And for the grad student version, you're only supposed to unlock the lock if you successfully acquire the permit. If you don't acquire the permit, then you don't have to, or you should not be unlocking the lock, because you want it held when wait for permit gets called. Now let's turn our attention to some problems with try to get permit unlocked. This code should be very simple. It should just check to see whether or not there are any waiters in the queue, and whether or whether the permit count is greater than 0. If there are waiters in the queue, then you can't get the permit because somebody's waiting. If there are no waiters in the queue, but the permit count is 0, then you also can't proceed. So try to get permit unlocked will succeed if there's no waiters in the queue and if the permit count is greater than 0. So this whole check here just makes no sense at all. I don't know what it's doing, but it's wrong. It's doing strange things and removing something, which it shouldn't be doing. I wasn't quite sure if this condition was correct. It didn't look correct to me, but you might want to take a double check on that one. Now let's take a look at another problem. So first of all, as the comment says, you should not be synchronizing this code. This code is meant to factor out the logic to check whether or not something has been, whether or not you can make progress without blocking or waiting for on the wait queue. And as a consequence, it should not be synchronized. And for the undergrad version, you're going to call this in a different context. It gets called twice. For the grad version, it only gets called once, but the undergrad version gets called twice, which is why we don't want any synchronization in here. That gets handled elsewhere. And there definitely should not be calls to try to get permit or wait for permit. Those are the methods that call try to get permit unlocked. Well, let me rephrase that. Try to get permit calls try to get permit unlocked. Try to get permit unlocked should be called first before wait permit is called, and then wait permit will call it under some circumstances. So again, just be you don't be calling these other methods here. There's no need to have a catch clause, and you should return the appropriate value, not just always return false. So lots of problems there. Now we get to what is clearly the hardest method in the whole assignment, wait for permit. And this method is what actually implements the specific notification pattern. So up to this point, those other methods like try to get permit unlocked, they are trying to do the happy path. The happy path is the path, or the fast path as it's sometimes called. That's the path where there's no need to wait. But when we need to wait, that's where the tricky logic comes in. So all kinds of problems here. I'm going to walk through most of the ones that I saw that were an issue and try to help explain what's wrong and give you some hints on how to fix it. So first of all, there's a race condition here. Since the wait queue is not synchronized, there should be synchronization. Synchronization is very tricky. That's why you need to read the Tom Cargill article and also watch my video that walks through this stuff. It explains kind of how you nest the synchronization blocks. This code doesn't implement the specific notification pattern at all, so please rewatch my videos and reread Tom Cargill's paper. I'm just not sure what's going on here, but it's wildly inadequate. So I'm not going to try to debug that one because it's just so incomplete. This assignment, this particular solution is also very incomplete. There's a race condition here again. You're not synchronizing things. This is the wrong loop condition to check in the while loop. You want to be checking something else. You want to be checking the M released field in the waiter, and the wait call here. That's fine, but you need to make sure you call it in the loop correctly. The other problem here is there's no proper synchronization of the waiter. So before you can wait on something, you need to first have synchronized with it. So you make sure you synchronize that properly. And then there's never a need to decrement permits. I should change this to permits or whatever you call it. You never need to decrement permits. That's handled by release. Release handles all the stuff having to do with that. And if you did need to decrement permits, which you don't, this code would not be correct because it has race conditions, because there's no synchronized statement that's protecting it. So now let's take a look at this. This is the grad student version of things, so it's a little bit different. The grad student version doesn't need to call try to get permit unlocked, because that's all handled earlier before wait for permit is called. The try to get permit method for the grad student version acquires the lock and holds it if it's unable to acquire or unable to obtain a permit. So by the time wait for permit is called, that lock is held. That's one of the main differences between the grad student and the undergrad version. The grad student version uses reentrant lock, and therefore it's more flexible because you don't have to unlock a reentrant lock when you leave a method. Whereas with a synchronized statement, you always have to release the lock, or the lock will be released on your behalf every time a synchronized statement is exited. So that's why you have to try to get permit unlocked in the undergrad version, because there's no way to keep that lock held across synchronized statements. All right, so now let's come down here. This lock needs to be locked a lot earlier, right before the very outermost, or right before the outermost try block. You need to acquire the waiter lock. So that needs to be moved way up to the front, or close to the front of the method. There's a lot of code missing here in the interrupt. In the interrupt exception catch clause, that's where you have to check to see. That's how you have to try to remove the item from the wait queue, and then do some release if needed. And so again, watch the video; it'll explain it. And then this lock here should be locked at the very end, and it should be basically pegged with the earlier acquire or lock of the waiter lock. So this is in the wrong place here. And this is also the wrong lock to unlock here as well. So you need to rethink the lock ordering. And the best way to learn how to do that properly is to take a look at the Tom Cargill article, because it explains, I think it's in maybe listing 3, it shows some code that illustrates how to do the proper locking protocol for the specific notification pattern. All right, continuing on with problems. There's all kinds of problems here. It's got race conditions because it's not synchronized all over the place. You can't just call waiter.wait. You have to have that be synchronized. You need to be calling that in a loop. So there's just all kinds of stuff missing. I'm not going to go through that in detail, but again, watch the video and read the article by Tom Cargill. Here's another problem. This has got the lock synchronization in the wrong order. You need to synchronize on the waiter first, and then synchronize on this, but only when you're making changes to instance variables in the fair semaphore MO class, or fair semaphore CO class if you're doing the grad student version. So you got to rethink the way you do the locking. You need to do it in the opposite order. Wasn't quite sure why the mReleased field was being set to false. That's not correct. But at the very least, you need to make sure that when you go into a loop here, sorry, when you call wait, you need to make sure you're calling that in a loop. Remember, you always, always, always wait for things in a loop. That's the basic rule of using condition objects or condition variables or whatnot. So make sure you have it in a loop, and it should be looping while waiter.mReleased is false. So you want to keep looping until it's been released. Let's come down here and take a look at some more problems. This is the undergrad version again. This code has a race condition since the waiter state is being accessed without being synchronized. This should not even be done, however. This is not the proper, this is not the proper time, place to check waiter mRelease. That doesn't belong there. That goes in when you do the loop. This is synchronizing on the wrong thing. So let's see. So we're synchronizing on waiter here, but that's the wrong thing to do. The intrinsic lock needs to be held here, not the waiter lock. So that's kind of backwards again. There's a race condition here because the intrinsic lock is not held. You're calling try to get permit unlocked. That doesn't do any locking. Once again, the ordering is backwards. So in this particular case, well, I guess I shouldn't say backwards. It's just doing this in the wrong place altogether. Always call wait in a loop and make sure to check the proper condition, which is mReleased. Then again, here's the catch clause, which is what gets run when an interrupt exception occurs. This has got a race condition since the intrinsic lock isn't held. So again, you have to think really carefully about which lock you need to hold when. And as always, you want to make sure you hold the locks over the proper scope. Let's take a look down here. So this code has got all kinds of weird problems. For some reason, this is actually correct, synchronizing it, the waiter first, followed by synchronizing this. That is correct. However, you need to nest all this code here under the code in there. And you need to do this because otherwise you'll have race conditions and other kinds of problems and so on. So if you do this properly, then you don't have to have a second synchronized waiter block. So just have to kind of clean things up a bit. Take a look down here. Make sure that you synchronize the waiter first before you synchronize on this. That's a common point I've raised. And down here, you don't need to have synchronized waiter again. That should have been done way up here before you get into that other part. And however, you do need to make sure that this is synchronized, which would be the case if you indented this stuff properly. And this code up here should be nested under the initial synchronized waiter block above. It shouldn't be down here. You shouldn't need to do synchronized on waiter twice. Some more problems. Only add the waiter to the wait queue if the call to try to get permit unlocked returns false. This again is the undergrad version. So don't just unilaterally add it. You only want to add it if you weren't able to obtain it. And again, please make sure that you call wait in a loop and use the mReleased field as part of the loop condition. Now we can finally turn our attention to problems with release. So I would say by far, wait for permit had the most issues, but release is probably not too far behind, although it's not as complicated of a method. So first, couple things here. Peek first doesn't remove the item. You actually want to remove the item, and I would recommend you use poll to do that. That's a better way to do things. This code here will fail if first equals null. There's no reason why there needs to be anything on the wait queue. In fact, that's a perfectly legitimate condition, is not to have anything waiting. So in that case, you get a null, and then if you get a null, you're down here trying to do something with that null, like get its access to a field or call a method on it, and that will blow up and fail with a Java null pointer exception. Down here, there's no need to call notify all. It's too unnecessary. Instead, just call notify. You don't need to notify all. You're only notifying one specific thread. That's why it's the specific notification pattern. And so when you call notify, it's perfectly fine to call notify because there's only ever going to be one waiter. Let's see, since there's only ever one waiter, one waiting thread per waiter object. So use notify. All right. This implementation is just completely incomplete, incorrect, and full of race conditions. Doesn't have any synchronization. It's not, I don't even know what it's trying to do, but it's very wrong. So you have to think about that more carefully. Only increment num permits if the wait queue is empty. So if the wait queue is not empty, you're just going to pass the waiter back to acquire, and you don't have to fiddle around with the permit count at all because you're basically taking something off the queue and just giving it to somebody else. So it doesn't change permit count at all. This particular implementation is missing a bunch of things. There's no synchronization. It's not setting the mReleased flag, so it's got a bunch of problems. Another thing, some people had the code that was more or less correct, but they are locking for too broad of a scope. So you don't actually have to hold the intrinsic lock for the entire release method. You only have to hold it long enough to access the state that's part of the fair semaphore MO or fair semaphore CO. And that would be the wait queue and incrementing the permit count. So you can refactor the code so that all that stuff can be done in a section that's synchronizing on this. And then after that, you can go ahead and synchronize on the waiter. And this has some other problems. This code should be factored out so that you can move it up to the synchronize this part. And you are also calling notify on the wrong object. Boy, is this going to cause you a headache because you're notifying on this object, but you want to be notifying on the waiter object because otherwise you won't be able to wake up the thread that's waiting. Let's go down and look at some more stuff. Here's release. So I left out some stuff here, but basically you don't need to use isEmpty and you don't need to use pop. Just use poll. That's a much more concise and clean way to do things. And then something important is missing here. It's not notifying the thread, so nothing will ever wake up. This code absolutely will not pass the test, so make sure you run the unit test and figure out what's going on. There shouldn't be a need for two synchronization sections here. As I said, you can refactor the code so that you do that all in one. Synchronize this statement. Just have to be a little clever with your logic. And same thing here, you need to refactor this so that you don't hold the intrinsic lock too long. And then down here, the point of release is to notify a waiter, not to wait on the waiter. That will also just never go anywhere. You'll just basically deadlock and never make any progress. And there's no need to have a catch clause here at all. Let's see, a couple more problems with release. So you can clean things up by using the poll method instead of isEmpty and remove first. And again, this code is redundant with the one above. You can refactor this code to make it have fewer synchronized this statements. This code is completely lacking in synchronized statements. You need at least two of them, and it doesn't have any, and it's also very incomplete, so it's not going to work. This code also doesn't have any synchronized this statement, so it's going to have race conditions. Please use poll instead of get first and remove first, or isEmpty. And you don't need isEmpty, get first, and remove first. You don't need all those three things. And I'm not sure what is even going on here. Some important stuff is missing here. In particular, things aren't being set, and you don't need to. It's not setting the mReleased field to true, and you don't need to check whether the permits count is greater than 0. Just notify. And this is also going to be a race condition because it's not synchronized at all. Okay, at long last, we can move out of the problems with the fair semaphore implementation, which you can see is the vast majority of problems. But there were also some problems with the Palantiri manager code. So this particular code isn't initializing the entries in the map correctly. I'm not sure what it's doing, but it's not doing what you think it's doing. And this code is passing the wrong parameter to the fair semaphore MO constructor. You want to give it the number of Palantiri, not 1. I'm not quite sure what the point of doing 1 was, but it's wrong. Here, the wrong type of map is being created. You want to have a concurrent hash map, not a hash map. And you can also zap those types. You can just do the little diamond syntax here, and Java will deduce the right types. And please also use a for each method as opposed to a for each loop. Not a big deal, but it just gets you in the habit of using Java functional programming features more consistently. All right, let's go into acquire. Lots of interesting things with acquire. A lot of people did acquire right, so good job. But other people got confused and tried to be too clever. So first of all, even though it doesn't matter here, for this particular example, please get in the habit of always moving your acquire or lock methods before the try method. Before the try block. Just a good habit to get into. Don't use Java streams here. I know I've been telling you to use Java streams a lot, and normally that's a good thing to use. In this particular case, I think it's not going to get you what you want. So instead use nested for each loops, and we'll talk about that in a second, and use the 3-parameter version of concurrent hash map replace. The reason we want to use the 3-parameter version of concurrent hash map replace is because it's the one that does the clever atomic check then act sort of compare and swap operation. And so it's super fast, super optimized. And there's no need to catch interrupted exception just to turn around and throw interrupted exception. Just let it throw itself, and so much for the better. Let's take another look at ways of doing the acquire method incorrectly. So what you want is 2 nested loops. And the outer loop should be a forever loop. So this is the forever loop. Just say for open paren, semicolon, semicolon, close paren. That's called a forever loop. And you want that one at the outermost level because you're not ever locking the entire concurrent hash map. That's the beauty of doing this. But as a consequence, due to scheduling order, it could be the case that because of weird scheduling order, you don't necessarily get a hit on the first pass through the loop. So you may have to loop more than once. But you'll eventually get it, and it won't take very long. Now, a couple things. Please use key set instead of entry set. No need to use key set. No need to use entry set. It just makes things more complicated. And in particular, do not use get value and set value on the entry set because those methods don't provide atomic semantics. Excuse me. And what you want to be able to do is have atomic semantics. And for that, you're going to need replace. So this code is very, very broken, very, very buggy. Similar kind of problem down here. This code is using key set correctly, so that's good. But definitely don't be using get followed by replace. That completely defeats the purpose of using replace. The purpose of using replace is to be able to do that. The 3-parameter version of replace is to do that atomic check then act operation. So don't use get. And then secondly, don't use the 2-parameter version of replace. You want to use the 3-parameter version of replace. The 2-parameter version of replace will replace the value. That's not what you want to do. You only want to replace the value if it's currently the value that you want it to be. And that's why we're doing this in a loop. So think very carefully about that. It's really key to understanding why the concurrent hash map is so powerful in this context. And then this particular approach is also incorrect. You don't need to have a separate call to replace if you use the proper forever loop and at the outermost part, and then you use the 3-parameter version of replace. Now let's turn our attention to problems with release. So I think this code is backwards. You don't want the thing to be equal to true. You want it to be equal to false. So that'll be incorrect. And you don't need the catch clause. You do need the finally clause, but for this to work, you need to make sure that you set this to boolean.false.equals, not boolean.true.equals. Down here, again, I think I've said this numerous times in various videos. The whole point of this stuff is to be atomic. So calling contains key followed by something else is not atomic. Those are 2 operations. There's a window between them. You will not get the atomic behavior that's so essential here. And number 2, don't be using the 3-parameter version of replace here in release. use the 2-parameter version. Why? The 3-parameter version will fail if the current value isn't false, whereas you want to set the value to be true. You unilaterally want to make it true. You're saying, replace this thing with true. And then, of course, you figure out what its current value was so you can call release properly on the semaphore. That reminds me of this last issue here. So make sure to check whether the Palantiri is null before you do anything else. That, again, is absolutely caught with the unit tests. So if you run the unit tests, you need to run the unit tests, you would find out that that was a bug. And down here, don't use synchronization. Don't use synchronize this. That was the whole point of using the concurrent hash map, was to avoid having to do any holistic synchronization of the whole map. You're just doing the very clever compare and swap synchronization that replace does with the 3-parameter version. And then down here, when you call put, you need to check the return value, and then you need to take that into account when you decide if you want to call release or not. A lot of this stuff is left over. That kind of stuff is left over from assignment 2B. So make sure that you have fixed that problem in assignment 2B. If you don't fix that problem in assignment 2B, you will lose points. And remember that the grading is cumulative. So you have to make sure that all the tests pass for previous assignments. I should note that we're always updating previous tests to try to do a better job of automatically detecting problems. So just because something happened to work in the tests from a previous assignment doesn't mean it won't work in subsequent assignments. So you have to make sure you go back and fix those problems as well. Okay, so that is the end of the walkthrough of the frequently made mistakes for assignment 3B. As you can see, it's much more complicated than the other assignments. So make sure you take some time and look at this stuff. And if you have questions, come to office hours.